Hey, let's do something fun today. Let's build an ESP32 motion-activated camera to capture every moment. Or movement. Yeah, every movement. I like the way the pictures turn out on this. I mean, for $20, it's not bad, it's not great, but the picture quality is good. We haven't seen the video quality yet. We've only been just snapping pictures, but I hope you're joining us as we learn to use this little board. It's been a lot of fun, and we have more projects to post here on our channel, so make sure you check those out. Let's get started. Today we'll be using the ESP32 S3, the HCSR501 motion sensor, some jumper wires, a button, 2 of the 10K ohm resistors, and a breadboard. I purchased my board from Amazon and it came with what you see here, including the camera. Here's the wiring for our setup, and it's pretty simple. I have the ground pin of the board connected to this ground rail right here, just for convenience. So the ground pin of the motion sensor is connected to that ground rail, and the data pin of the motion sensor is connected to pin 21 on the board, and the positive pin of the motion sensor is connected to pin 5 over here on the board. And down here I have a button, and there are 2 pins on the bottom of the button, one connected to the ground rail and the other one is connected to pin 42 using a 10K ohm resistor, and the top pin, top left pin for me, of the button is connected to the 3-volt pin, and I'm using a 10K resistor there as well. Here is a wiring diagram to answer any questions you may have about the connections. If you remember in the last video, we downloaded the Freenove Basic Starter Kit from the Freenove website. If you haven't seen that video, I'll link it in the description. But if you have a brand new board, you want to be sure to install the CH343 driver. It is included for Linux, Mac, and Windows. You just click on it and you run that executable file. But let's go back here. Now this is available in Python, but we're going to use the C language, and we're going to go to the sketches here that are available to us through that download, and we're going to scroll down to 17.3 camera SD card. Now in the Arduino projects, especially the more complex ones, it's common to organize code across multiple files, and you'll see that in the tabs in the Arduino IDE sketch. And it's done this way to improve readability, and it's easier to maintain. You can think of it as breaking down a system into smaller, manageable, and interchangeable parts that can be independently developed or tested and maintained. But today we're going to use tutorial example 17.3 and only modify the code on the .ino tab. If you want the modified code for the .ino tab, check the description for details. Now the first thing we're going to do is open the library manager and type in Freenove WS2812. We want that library for the ESP32, and we'll install that. The sketch that's included in the tutorial requires you to press the boot button on the board to take a picture, but we also wanted to add a motion activated picture option, and I wanted to change the button press option to take a picture to pin 42. So let's go ahead and do that. As you're looking at your pinout, you may notice that the boot button is connected to pin 0, so you could keep your button pin there. The only reason I moved the button to pin 42 was to keep it out of the way of the 3 leads that I'm using for the motion sensor, which is pin 21, ground, and 5-volt. Now this is the camera SD card sketch that's included in the tutorial with some modifications. We start off including the ESP camera library with some header files that you'll see there on the tabs above, and those handle different functionalities. The button pin and the motion sensor pin are defined to specify the GPIO pins connected to the button and to the motion sensor. The motion detected variable is a flag to track the state of motion detection, and there's also a camera setup function to set up the camera. The setup function initializes serial communication and configures the GPIO pins for the button and motion sensor. It initializes the WS2812 LED and SD card functionalities. It also creates and lists directories on the SD card. The setup function also calls the camera setup function to configure the camera settings, and depending on the success of the camera setup, it sets the WS2812 LED caller. If the setup fails, it terminates the setup function early. The loop function continuously checks the state of the button and motion sensor. If a button is pressed, it captures a photo with a label indicating the trigger was a button press. If motion is detected and it was not previously detected, it captures a photo with a label indicating the trigger was motion, and then it sets the motion detection flag, and if no motion is detected, it will reset that flag. The capture photo function is responsible for handling the photo capture and storage. It turns on the LED, logs and triggers events, and attempts to capture a photo. The camera setup function configures various parameters such as pin assignments, resolution, pixel format, and frame buffer settings, based on the presence of PS RAM. It's here that you can adjust the camera sensor settings such as vertical flip, brightness, and saturation. If you take a picture and you see that your image is upside down and the vertical flip is enabled, you can disable it by setting it to 0. Alright, we've got our sketch ready and ready to upload. We've got our board plugged into the computer. So let's go ahead and click upload. Make sure that's connected to COM9. Have your board selected. Alright, so now when we press the button, it should take a picture. Button pressed. Photo taken. And now motion should also activate a picture taken. Motion detected. Maybe for motion you'll see my hand in the picture. Alright. Photo taken. Let's say the button press will show a screwdriver in the picture. Alright. And then motion activated picture, you'll see my hand. There we go. And it should be one image for each. That's all there is to it. That's a picture is taken every time a button is pressed or motion is detected. When the camera is on and active, that blue light comes on. Well, that's all I have today. Thank you for watching. Hopefully it was helpful to you. If it was, be sure to like by clicking the thumbs up. Also consider subscribing. You can check out our Facebook page and our other videos. Also leave a comment below. I'd love to hear from you. I'll see you again with another video.